This video is going to review and answer the question, how do you transform a function using shifts, stretches, shrinks, and rotations? And we're looking at an equation, y equals, and those shifts, stretches, shrinks, and rotation come from multiplying a function on the outside, on the inside, adding and subtracting from the function on the inside and on the outside. And what I want to do is create a table that's going to help us organize exactly what happens when we perform these operations on the function and on the x on the inside, and see what the transformations that result are. So we're going to look at what happens when we add or subtract from the function itself, in other words on the outside of the function, or what happens when we add or subtract from the x on the inside. Well, on the outside of the function, we're talking about k. K is the part of this that is the adding or the subtracting on the inside, on the outside of the function. So what does happen when we do that? That causes a shift in the graph, up if we're adding, down if we're subtracting, and we're shifting k units, up or down. Well, adding or subtracting x is the h on the inside of the graph. Right here is the h. And what happens to the graph when we add or subtract from x on the inside? That causes a shift. Left if we add, right if we subtract. And the shift is h units, whatever the value of h is. Causes a shift, left and right. So that's what h and k do. They shift our graph up, down, left, and right. Now what happens if we multiply times the outside of the function? Well, that's a. A is what multiplies the outside of the function. So what does that do? Well, if the absolute value of a is greater than 1, this causes a vertical stretch. And if the absolute value of a is less than 1, this causes a vertical shrink to the graph. And what if we multiply on the inside to the x? So now we're talking about b. B is multiplying the x on the inside. When we do that, based on the absolute value of b, if it's greater than 1, that causes the graph to horizontally shrink. And if the absolute value of b is less than 1, that causes a horizontal stretch. Now, one of the differences between multiplying a on the outside and multiplying b on the inside is that the vertical stretching and shrinking are all by a factor of a. So we stretch by whatever a is, we shrink by whatever a is. Horizontally, however, we horizontally shrink or stretch by a factor of 1 over b, the reciprocal of b. So if b is 2, that's going to cause a horizontal shrink of 1/2. If b is 1/2, that'll cause a horizontal stretch of 2. And then the last thing we want to look at is what happens when we take the negative. What happens when we have a negative f of x? So again, this is a. When a is negative for f of x, that's going to cause a reflection, or we're going to reflect the graph across the x-axis. And what happens when there's a negative in front of the x? So that's b. Whenever b is negative, that's going to cause our graph to reflect across the y-axis. And this table summarizes exactly what happens when a graph is transformed by shifting, stretching, shrinking, rotation, and where that results from. It results from multiplying a on the outside, multiplying b on the inside, adding or subtracting h on the inside, adding or subtracting k on the outside.